Hello guys, welcome to today's video. In this video we're going to talk about the limits of a function, and we have 7 methods in which we can solve for the limits of a function. So the first method is direct substitution method. So I'm going to take an example involving the direct substitution method. So we're given a question: the limit of x squared minus 5x plus 8 as x approaches 3. So what we do, direct substitution simply means wherever we see x in this equation, we're going to put 3. So using that, we're going to have here 3 squared minus 5 all into 3 plus 8. So 3 squared simply means 3 times 3, which is 9, minus 5 times 3 is 15, plus 8. So when you 9 minus 15 plus 8, we are going to have 2. So this is what we mean when you solve for the limits of a function, including involving direct substitution. So the next method is the quadratic method. Quadratic method. So let's take a question. We have the limits of x minus 2 over x squared plus 4x minus 12 as x approaches 2. So in this case, we are going to start by solving with the denominator. So taking the denominator, which is x squared plus 4x minus 12. So what do we do? I'm going to give you an easy method in which you can factorize this to a simpler terms. So we can take this value and this value. When we multiply them, we're going to have minus 12x squared. So we're going to look for a number that when you multiply them, we're going to have minus 12x squared. And when you add them together, we're going to have 4x. So the two numbers that comes to mind is 6 and minus 2. So making use of 6x and minus 2x. Because when you multiply 6 minus 2, we're going to have minus 12x. And when you subtract 6 minus 2, we're going to have 4x. So in place of 4, we're going to put 6x and minus 2x. So we're going to have x squared plus 6x minus 2x minus 12. So can now factorize easily. So in place of this, what's common between these two? We have x. So there's x remaining here, x plus 6. What's common between this is 2. So we have 2 here into x plus 6. Here's a positive sign because when we multiply minus times plus, we're going to have minus. So that's why it's like, so we're going to, since we have two values that are the same, we're just going to pick at 1. So we're going to have x minus 2, then x plus 6. So now in place of x squared plus 4x minus 12, we're going to put these values. So putting them into the function, we're going to have the limits as x approaches 2. We have x minus 2 into x minus 2, x plus 6. So now this and this are going to cancel out. So I'm going to have the limit of x approaches 2 becomes 1 all into x plus 6. So therefore, to look for the limits, we're going to have, wherever we see x, we put 2. So we're going to have 1 into 2 plus 6, which is going to give us 1 over 8. So this is the answer when you have a question involving quadratic. This is the method you use to solve. Now we're going to look into the next method, which is infinity. When we have a number that approaches infinity. Alright, now we're given a question. The limits Now, given a question like this, what we need to do, the first thing we need to do, you notice this question is in power. So I'm going to take the highest power of x. So taking the highest power of x, the highest power of x in this is 4. So we're going to divide all through with the highest power of x. So this is going to be the limit as x approaches infinity. So we divide through by it. We're going to have x raised to the power 3 divided by x raised to the power 4 minus 2 all into x raised to the power 4, which is the highest power of x, divided by, we have 5x raised to the power 4 all into x raised to the power 4 minus x. So we are dividing through with the highest power of x. So going to continue the limit as x approaches infinity. When we divide this, we're going to have 1 over x minus 2 into x to the power 4. Then here we're going to have 5 minus 3 all into x plus 2 all into x cubed when we divide by the power of x. So now it's so easy for us to impute wherever we see x, we are going to put infinity. But note that, you should always note that any value dividing infinity is equal to 0. Any value dividing infinity is equal to 0. That is, for example, if we have 5 divided by infinity is equal to 0. So any value dividing infinity is equal to 0. So we can continue by saying, now for us to get the limits of this function, so we need to put infinity wherever we see x. So we're going to have 1 over infinity minus 2 into infinity, all this. So we have 5 minus 3 dividing infinity plus 2 dividing infinity all cubed. So remember I said any number dividing infinity is equal to 0. So in this case we're going to have, so in this case we're going to have 1, so we're going to have 0 plus 0 all into 5 minus 0 plus 0. So it is going to be a negative sign. So I'm going to have 0 all into 5, which is equal to 0. So this is how you solve when you have a question involving infinity. So I'm going to go into the fourth method, which is involving polynomials. When you have a question involving polynomials, the fourth method involving polynomials. Okay. Now, given a question, the limits x squared plus 3x minus 5 as x approaches minus 3. So this simply means we are going to break it down into a very simpler form so that it will be so easy for us to solve for the limit. So breaking this into simpler parts, we are going to have the limits of x squared plus the limits of 3 times the limits of x minus the limits of 5 as x approaches minus 3. So we are going to break it into the simpler form, but note that the limit of any number is equal to that number. So now wherever we see x, we are going to put minus 3. So in this point, we are going to have minus 3 squared plus 3 times minus 3 minus 5. So minus 3 squared is something as minus 3 times minus 3, which is going to give us 9. So I'm going to have 9 minus 9, which is 3 times minus 3, minus 5. So this is going to have 0 minus 5, which is equal to minus 5. So this is how you solve for problems involving polynomials. So I'm going to go into the fifth method, which involves using the L'Hospital's rule. And the L'Hospital's rule involves the use of differentiation. So I'm going to solve a question which involves using differentiation. Okay, so I'm going to get question. We have the limit of x plus 2 over x squared plus 3x plus 2 as x approaches 2. So in this case, this is what we're going to do. We're going to differentiate both the numerator and the denominator. We're going to differentiate both the numerator and the denominator. So we can write this as the limit as x approaches 2 So when we differentiate this, we are going to have the limit as x approaches 2. When we differentiate x plus 2, we are going to have 1. And when we differentiate this, we are going to have 2x plus 3. So now it's very easy for us to look for the limit. So solving for the limit, wherever we see x, we are going to input 2. So we're going to have 1 into 2 plus 3. Which is going to give us 1 into 2 times 2, 4, plus 3, which is going to give us 1 over 7. So these are solved using the L'Hospital rule. So we're going to go into the sixth method, which involves perfect square. When you have a question involving a perfect square, involving a perfect square. Now, what is a perfect square? Perfect square are those numbers that when you look for the square root, you are going to have that's a number that have a square root. For example, we have 16. The square root of 16 is 4. So therefore, a perfect square. So we have a perfect square. So 16 is a perfect square. So that's what we mean by perfect square. So we're going to get a question that involves a perfect square, which is we have to look for the limits of x squared minus 16 over x minus 4 as x approaches 2. Now, since 16 is a perfect square, so we need to simplify x squared minus 16 so that it will be so easy for us to look for the limits. So since 16 is a perfect square and the square root of 16 is 4, so we can easily write this x squared minus 16 can be written as x minus 4 x plus 4. When we expand this bracket, we're going to have this. So now in place of x squared minus 16, we're going to put this. So we're going to have the limits as x approaches 2. We're going to have x minus 4 x plus 4 all into x minus 4. So this can easily cancel out. So I'm going to have the limit as x approaches 2 to be x plus 4. So wherever we see 2, we're going to put, wherever we see x, we're going to put 2. So therefore this can be 2 plus 4, which is going to give us 6. So we're going to go to the last method, which is by rationalizing. That is solving the limit of a function that involves roots. So seventh method, which is by rationalizing. So we have in the question which says the limit of x minus 25 divided by the root of x minus 5 as x approaches 25. Now, that's what we're going to do. We're going to bring out the equation, the limits as x approaches 25. We're going to have x minus 25. Now we're going to use the denominator to multiply all through, and the sign of that denominator changes, which is to say the sign in the denominator is plus, which is when we are going to use it to multiply, that negative sign is going to turn to a positive sign. So we're going to have something like this. So we're going to have so when we continue, this is going to become, multiply this both of them, we're going to have something like this. Multiply. So yeah, we're going to have root of x times the root of x is going to give, the root is going to cancel each other, so we're going to have just x. So minus 5 times plus 5, we're going to have minus 25. So being it like this, we can easily cancel out, which is say this is going to cancel this out. So I'm going to have the limits of x when it approaches 25. So I'm going to have the root of x plus 5. So whenever we see x, we put 25. So I'm going to have the limits as x approaches 25. We're going to have, so putting it in, we're going to have 25, the root of 25 plus 5, which is going to give us 5 plus 5, which is going to give us 10. So this is how you solve for the limits of a function involving the 7 method. I hope this video is very helpful.